So in today's session we are going to see gas chromatography. Gas chromatography. We have seen column chromatography. Now in that column chromatography, actually this gas chromatography, then HPLC high performance liquid chromatography, both are the types of column chromatography. तो कॉलम क्रोमेटोग्राफी में डिफरेंट डिफरेंट टाइप्स होता है। जैसे एक होता है कि जो आपका कन्वेंशनल कॉलम क्रोमेटोग्राफी, जिसमें आप लेबोरेटरी स्केल के ऊपर कॉलम प्रिपेयर करते हो और उससे दैट इज नोन एज अ प्रिपरेटिव कॉलम क्रोमेटोग्राफी। दूसरा एक होता है एनालिटिकल के लिए यूज होता है एचपीएलसी हाई परफॉर्मेंस लिक्विड क्रोमेटोग्राफी, और एक होता है गैस क्रोमेटोग्राफी। सो ऑल दीज आर द टाइप्स ऑफ कॉलम क्रोमेटोग्राफी। जिसमें कॉलम इन्वॉल्व है उसको बोलेंगे कॉलम क्रोमेटोग्राफी। जिसमें कॉलम नहीं है, जिसमें क्या है लेयर है, जैसे थिन लेयर क्रोमेटोग्राफी, उसमें क्या है एडसॉर्बेंट या स्टेशनरी फेज का है, एक लेयर होता है स्टेशनरी फेज का। इसमें क्या है कि कॉलम एज अ स्टेशनरी फेज। So remember, conventional column chromatography is different, then HPLC is different, and gas chromatography is different. So in case of conventional chromatography, so what is the stationary phase and what is the mobile phase? So obviously, stationary phase is nothing but the adsorbent packed in the column or burette. That is nothing but the stationary phase, and whatever mobile phase may be, it may be a mixture of two or three different solvents. Okay, that is nothing but the conventional column chromatography. In case of HPLC, so column length decreases. Okay, जो कन्वेंशनल क्रोमेटोग्राफी में कॉलम जो बड़ा वाला कॉलम था, सो इन कन्वेंशनल क्रोमेटोग्राफी लेंथ ऑफ कॉलम में बी अप टू 20 सेंटीमीटर 30 centimeters, and internal diameter may be around 1 centimeter or 2 centimeter. But in case of HPLC, the column height, column length, column width, and the packing of material, that is changes. Okay, that is changed. In case of HPLC, column length is very less, it is around 10 to 15 centimeter. Column width is also very less, again 0.5 mm in diameter. So whatever the stationary phase is there, so that is also a very that is also having very small particle size. In case of हे दोघे जण गेली व्हाय, परत एकदा मेसेज टाकू ग्रुपमध्ये, दोन जण होते जॉईन झाले, म्हटलं 4-5 मुलं आहेत सेशन घेऊया, तर ते गायब झाले. परत ते मला त्रास आहे फक्त, कारण इकडनं स्विच करा, इकडनं जॉईन करा, स्विच करा, जॉईन करा. Again, this gas chromatography is a kind of column chromatography, like your HPLC and conventional column chromatography. But the major difference in your column chromatography, HPLC and gas chromatography is nothing but the difference of mobile phase. So in case of conventional column chromatography, you are using a mixture, a solvent alone or a mixture of solvent in a various proportion as a mobile phase. In case of HPLC also you are using same thing. But in case of gas chromatography, so stationary phase will be a column, that is adsorbent packed in the column, or a thin layer of liquid on thin layer of liquid held by adsorbent in a column. So but mobile phase will be gas. Mobile phase will be gas. So what is gas chromatography? So remember, stationary phase is nothing but the stationary phase is nothing but the adsorbent packed in a column. Adsorbent packed in a column, and it may be either adsorbent only, or it may be either a liquid held by adsorbent. Okay, so depending upon the type of that. So there are two types of gas chromatography, but mobile phase will be your gas. Mobile phase will be gas. Mobile phase will be gas. So mobile phase is there in case in the cylinder, so gas cylinder. Okay, so it may be either helium, it may be either hydrogen, helium, okay, hydrogen, helium, and other gases, acetylene, then air is also there. So these gases, they are the mobile phase. Solid stationary phase is nothing but the either adsorbent packed in the column or liquid held by adsorbent in the column. So depending on that, there are two types of this gas chromatography: gas solid chromatography. So in that, solid is the stationary phase and gas is the mobile phase. Okay, so in that, adsorption phenomena is there. Adsorption phenomena is there for the separation. Now in case of gas liquid chromatography, GLC, gas solid मतलब GSC, gas solid chromatography, ये आपके upcoming slide में आने वाला है. So there are two types of gas chromatography: gas solid chromatography, gas liquid chromatography. So gas solid chromatography does not have much application in the pharmaceuticals, so that is not discussed much. But gas liquid chromatography will have definitely a wide variety of application in the pharmaceuticals. So that's why gas liquid chromatography is important. So it is just a diagrammatic representation of your gas chromatography. So in that you have different parts like carrier gas. Carrier gas. It may be either hydrogen, halogen, and hydrogen, halogen, oxygen, acetylene, etc., etc. So it is known as a carrier gas, which is there in a cylinder. So carrier gas is nothing but the mobile phase chromatography technique. So inert carrier gas mobile phase. Okay. Stationary phase is nothing but this column. Stationary phase. So column may be either straight or coiled or bent. Usually, as compared to HPLC, the column present in the gas chromatography having much length. इसका जो dimension length होता है column का ये बहुत ज़्यादा होता है from few centimeter to few meters. ये मीटर कुछ सेंटीमीटर लेके मीटर तक होता है ये कॉलम. Okay, that's why ये कॉलम का लेंथ बहुत ज़्यादा होता है HPLC की कंपैरिजन में. Carrier gas you are using as a mobile phase. Column is nothing but the stationary phase. So carrier gas will, okay, whatever sample you have, so carrier gas passed. Okay, now here is a regulators, flow regulator. So you have to control the flow. Okay, flow regulators. At this point gas is entering into a column. This is known as a sampling compartment. Okay, so यहाँ से आप sample inject कर सकते हो. Nowadays auto samplers are there, so automatically the machine will take desired quantity of sample, 1 microliter, 2 microliter. Okay, now it is just a diagrammatic representation. Okay, then, okay, now this carrier gas you are injected a sample. Okay, now this sample is taken by this carrier gas. Okay, carrier gas, it will move in the column. Now your sample has a different mixture. It is having different components, it is having different elements, it is having different drugs. So different components will be separated in the column, that is stationary phase. So mixture of your sample will be separated in the stationary phase, and mobile phase is nothing but the gas. So there are two mechanisms involved. So either adsorption mechanism is there or either partition mechanism is there. Now after that the separated components, okay, so whatever components they will be separated in this column according to their selective adsorption phenomena or different adsorption phenomena or different partition phenomena between the stationary phase and mobile phase. Now it will be eluted, eluted. Okay, it will be separated, it will be detected by detector, and it will be converted into a graphical representation. You will get a chromatographs. So that's how there is a simple gas chromatographic technique. It is not as simple as that. So it has a lot of parts and components. So remember, so in case of gas chromatography you are using a inert carrier gas as a mobile phase. Okay, so this will be mobile phase. Your sample will be a mixture. As this is a, as mobile phase is a gaseous, so mobile phase is nothing but the carrier gas. So your sample required to be in a vapor form. So you have to vaporize the sample. Whatever sample you have, you have to vaporize it by using heat. Okay, so then only this carrier gas can take that sample into column that will be separated according to the particular phenomena involved, either adsorption or partition, and then it will be detected. So these columns they are having more length as compared to other columns. Now these columns are placed in the oven. It is known as a oven. ये जो पूरा है oven है, known as a column oven. So these columns are maintained at a particular temperature because temperature will change the adsorption phenomenon also and partition also. Okay, so that's why particular temperature is important. So this carrier gas is nothing but the mobile phase. So it is the flow is regulated by regulator. Okay, the flow is very important. Again, your sample containing mixture, okay, sample will be taken inside the this column through by the carrier gas, by the movement of carrier gas, and it will be separated according to the phenomenon in the column. It will be detected and signal will be converted into a data chromatogram. So this is how the schematic representation of your gas chromatography. Now we'll see the individual parts. So what is gas chromatography again? A gas chromatography is again a type of chromatography quite similar to your column chromatography, except here we use a gas as a mobile phase. So here gas is used as a mobile phase instead of liquid. So in case of column chromatography, mobile phase was liquid. In case of HPLC also, mobile phase was a liquid. But in case of gas chromatography, you are using a gas, okay, inert gas. So it may be either hydrogen, helium, it may be either oxygen, acetylene, etc. So it is used as a mobile phase instead of liquid. Okay. Now there are two types of gas chromatography. First one is a gas solid chromatography, and second one is a gas liquid chromatography. So what is gas solid chromatography? So it is based upon the selective adsorption of selective adsorption on a solid. So in gas solid chromatography, gas is used as a mobile phase and column is a solid. Okay, so there is a solid column. That means there is some adsorbent in the column. So adsorbent packed in the column. So whatever components are, they will be separated according to their affinity towards the stationary phase. That is affinity of adsorption towards the stationary phase. That is a gas solid chromatography. Now gas liquid chromatography is what? So just replace that solid stationary phase with a thin layer of liquid. Okay. Now if gas is a mobile phase and stationary phase is what? Liquid held on a solid. Liquid thin film held on a solid. That is a gas solid. So, okay. So gas chromatography is divided into two types: gas solid chromatography and gas liquid chromatography. What is gas solid? So in case of gas solid chromatography, so your stationary phase is nothing but the solid, that's adsorbent. Okay, adsorbent packed in the column, and mobile phase is a gas. Okay, separation effected on the basis of selective adsorption on the adsorbent in the column. Okay, now in case of gas liquid chromatography, what is that? So gas is a mobile phase. Okay, gas is the mobile phase, and liquid held on a solid. Liquid held on a solid, that is nothing but the stationary phase. But in case of gas liquid chromatography, so your phenomenon of separation is nothing but the partition. Phenomenon of separation in the gas liquid chromatography is a partition, because there is a partition of your components of mixture. So in solid chromatography, solid stationary phase, that is adsorbent in the column, and gas is a mobile phase. So separation is based upon the selective adsorption of components on the adsorbent in gas solid chromatography. In gas liquid chromatography, so solid stationary phase is there. On that solid, liquid is held. A thin film of liquid held by solid. Now that is a stationary phase. In gas liquid chromatography, gas is a mobile phase, and liquid held on a solid, that is a mobile phase. That is a stationary phase. So there is a selective partition of your component between the gaseous state and liquid held on a solid stationary phase. So that is a gas liquid chromatography. Now, gas solid chromatography has very limited applications in the pharmaceuticals. So, gas liquid chromatography is most widely used. Gas liquid chromatography. तो gas liquid chromatography में gas as a mobile phase है और liquid held on a solid support. That is a stationary phase. Okay. So it is based upon the partition between gas, that is a mobile phase, and liquid stationary phase. Liquid is held on a porous support. Okay. That is a stationary phase. These are the two types of gas chromatography. Now, in gas liquid chromatography, the stationary phase is nothing but the liquid. Question आपको यहाँ से आ सकता है कि the stationary phase in the gas liquid chromatography. तो कंफ्यूज नहीं होने का है वहाँ पे gas liquid chromatography. ठीक है, आप बोलेंगे नहीं सर stationary phase तो solid ही होता है. That is wrong. Okay. Now, in case of adsorption, obviously that stationary phase is solid. But in case of partition, so stationary phase is nothing but the liquid held by solid. So in gas liquid chromatography, stationary phase is nothing but the liquid, and it is usually coated. Okay, a thin film of liquid. A thin film of liquid is coated on either solid matrix, that is diatomous. A thin film of liquid, okay, which is a coated on the wall of capillary tube. So that is a stationary phase. So in gas solid chromatography, stationary phase is solid. In gas liquid chromatography, stationary phase is a liquid held by solid. So remember, in gas solid chromatography, adsorption phenomenon is there. गैस सॉलिड क्रोमेटोग्राफी में सेपरेशन किसके बेसिस पे होता है? एडसॉर्प्शन. ठीक है, सिलेक्टिव एडसॉर्प्शन. आणि एंड इन केस ऑफ गैस लिक्विड क्रोमेटोग्राफी सेपरेशन किसके बेसिस पे होता है? सेपरेशन होता है इसके बेसिस पे, किसके? पार्टीशन. सो व्हाट इज द सेपरेशन बेसिस फॉर गैस सॉलिड क्रोमेटोग्राफी? दैट इज एडसॉर्प्शन. And what is the basis for gas liquid chromatography? That is nothing but the partition. So partition between gas and liquid held on a solid. That is the phenomenon. Okay. So these are the two types of gas chromatography depending upon the phenomenon and type of stationary phase involved. Okay. Now in case of gas liquid chromatography, stationary phase is liquid, which is usually coated on either solid matrix, that is diatomaceous earth, or they are coated on a capillary tube. Okay, in gas liquid chromatography. So gas liquid chromatography or gas and gas solid chromatography consists of the following basic compartment. So what are the different compartments of gas chromatography? So separation is carried out in a tabular column, which may be made up of either glass or metal or Teflon. Glass, metal means stainless steel, then Teflon. So in case of gas solid or gas liquid chromatography, separation is carried out in a tabular column made up of a glass or metal or Teflon. Now whatever adsorbent is there, that is filled as a stationary phase in the column. Okay, and column is packed in the form of size graded powder. So whatever adsorbent is there, जो भी adsorbent होगा आपका सिलिका केसलगर या फिर दूसरा कोई adsorbent, ठीक है, या फिर कोई पॉलीमर होगा, उसको एक साइज, उसका जो साइज है वो बहुत छोटा किया जाता है. इट इज अ reduced in size graded powder, so that powder is packed in the column. For the solid chromatography, gas solid chromatography, now for gas liquid chromatography, a thin film of solvent or thin film of solvent is applied on that graded powder, and that is packed in the column. So that is a, whereas liquid coated as a fine thin, okay, liquid coated as a thin film on a column, pre-coated with the fine sized graded porous support. तो गैस सॉलिड क्रोमेटोग्राफी के लिए कैसे कॉलम बनाएंगे आप? दैट इज नथिंग बट द, okay, so adsorbent adsorbent is stationary phase in the solid gas solid chromatography, and it is packed in the column in the form of size graded powder. जो पाउडर होता है वो मतलब साइज रिलेशन करने के बाद में बहुत माइक्रोन का साइज का पाउडर उसमें पैक किया जाता है, वो that will act as adsorbent in gas solid chromatography. Now in case of gas liquid chromatography, so that adsorbent जो है उसके ऊपर एक you have to apply a thin film of solvent. Either you can apply after packing, or nowadays pre-coated powder is available, pre-coated with a thin film of liquid, that is known as a fine sized graded porous support. They are also available. Now sample in the form of papers. Remember, sample in the form of paper. For gas chromatography, sample should be in a paper form, and for mass chromatography also, mass spectroscopy also, and for gas chromatography, sample should be in a vaporized form. क्वेश्चन आ चुका है कि मास स्पेक्ट्रोस्कोपी के लिए भी सैंपल क्या होना चाहिए? वेपराइज्ड होना चाहिए. So sample should be in a gaseous state, your mass spectroscopy, and for your gas chromatography also sample should be in a gaseous state. Okay, so most of the samples, they are not gaseous, they are either solid or liquid. Now you have to convert that solid or liquid into by application of heat. Okay, so sample in the form of paper along with the carrier gas, sample in the form of paper along with the carrier gas, it will enter into the column, it will enter into the column, and after separation, depending upon the phenomenon, either it may be adsorption or partition. So whatever comes out of the column, whatever separated component comes out of the column, they are known as a effluent, they are known as effluent. So carrier gas is nothing but the driving force for movement of sample in the zones through column, and the solid provides selective retarding force for the movement of, for the flow of gas. The detector is nothing but the brain of your column gas chromatography, and gas is nothing but the heart of gas chromatography. Okay? Sorry, the detector is nothing but the brain of gas chromatography, and the column is nothing but the heart of your. यहाँ पे क्या है कि सैंपल आपका जो है सैंपल इन द फॉर्म ऑफ वेपर्स along with the carrier gas, it will enter into the column after the separation, depending on the phenomenon, it may be either adsorption or partition, but mostly partition ही होता है. Whatever that will come out of the column is known as a effluent. Now carrier gas is driving force for the movement of your sample through the different zones of your column. Okay, and solid provides selective retarding force for the movement of your mobile phase. Now the detector used in the gas chromatography known as a brain of gas chromatography, and column is known as a heart of your gas chromatography. Remember. Now requirement of compound to be analyzed by GC, मतलब गैस क्रोमेटोग्राफी से कौन से कंपाउंड आप एनालाइज कर सकते हो, क्या क्या रिक्वायरमेंट होना चाहिए गैस क्रोमेटोग्राफी के लिए, सेपरेशन के लिए. फर्स्ट इज नथिंग बट द volatility. The sample should be volatile, compound should be volatile, so that it will be mixed up easily with the mobile phase, that is nothing but the gas. तो अगर आपका solid sample है तो वो गैस के साथ में कैसे मिक्स होगा? So you have to convert that solid sample or liquid sample into a gaseous state by application of heat. So volatility is a very important parameter of the compound to be analyzed by gas chromatography. तो gas chromatography के लिए sample क्या होना चाहिए? Vaporized होना चाहिए. तो उसका volatility होना चाहिए. So compound should be volatile. So बहुत सारे compound volatile नहीं होते. Most of the compounds they are either solid or they are liquid in nature. So you have to convert that solid sample or that liquid sample into vaporized state by application of heat. ठीक है? So volatility is the first component, first requirement to be fulfilled by your sample. Second requirement is thermostability. Suppose that your compound is not stable to heat. So suppose that your compound is solid and you have to convert into vapor by application of heat, and your compound is not stable to heat. So it is easily degraded by heat. So solid and liquid samples are converted into vapor by using heat. So compound should be stable. Okay, your compound should be thermostable. So you are using heat over here to convert the solid liquid sample into vapor. So your compound should be thermostability, thermal stability. Compounds which are not thermostable, they are not analyzed by gas chromatography. जो भी compounds, जो भी sample जो है आपका thermal stable नहीं है, मतलब heat stable नहीं है, thermolabile है. So if your sample is thermolabile, so you cannot use that sample in the gas chromatography. Okay. So only volatile, your sample should be have a volatility, and your sample should be stable to heat, thermostability. Then only you can use that sample for gas chromatography. As we have seen different components of your gas chromatography, what are the different components of gas chromatography instrument? First will be the carrier gas, second will be the regulator, third will be the sample injection port or sample handling system, fourth will be the column. Okay, fifth component will be the column oven or heaters. Then sixth component will be the detectors. Okay, seventh and eighth component will be the uh, nothing but the recorders and integration. Okay, integrate and recorders and plotters, that's it. So there are 5 or 6 component of your gas chromatography. So I have not listed here because we are not studying for your semester exam. इस सेमेस्टर के लिए नहीं, तो ऐसा पूरा लाइन लिखूंगा मैं. गैस क्रोमेटोग्राफी कंसिस्ट ऑफ फॉलोइंग कंपोनेंट: कैरियर गैस, दूसरा आपका जो सैंपल हैंडलिंग सिस्टम, तीसरा कॉलम, चौथा कॉलम ओवन, पांचवा डिटेक्टर, सिक्स नंबर इन जो आपका प्लॉटर्स या फिर जो भी है. सो that practice is not here. Okay, so here only we are dealing with the important points for your GPAT and authorization. So first is nothing but the carrier gas. So carrier gas is nothing but the mobile phase. ये क्या है आपका मोबाइल फेज. So carrier gases like hydrogen, helium, nitrogen, air, they are used. Okay, remember gases like hydrogen, then helium, then nitrogen, they are used. Okay, so out of that, helium is most commonly used. Helium is most commonly used as a mobile phase, gaseous mobile phase for the gas chromatography. Remember, helium is the most commonly used. Now hydrogen है आपका, helium है, nitrogen है, and आपका air है. So they are used as a mobile phase. But out of that, helium is the most commonly used mobile phase because helium क्या होता है? It is a inert. It is a inert to most of the compounds. That's why helium is used. It has a more thermal capacity. Okay, जैसे आपका हाइड्रोजन है. For example, if you take hydrogen, so hydrogen can interact with your compound. Hydrogen may react with your compound. So hydrogen react हो सकता है अगर आपके compound में double bonds तो वो वहाँ पे saturation कर देगा. So hydrogen can react with the compound. उसका thermal stability भी होना चाहिए. इसका thermal stability बहुत अच्छा होता है hydrogen का. But it can react with your compound. So helium, nitrogen. So every carrier gas has its own advantages and disadvantages. If you want to read that, you can read from books. Okay, but remember, question may come like one of the following gas is most commonly used as a carrier gas or mobile phase in the gas chromatography. So helium is most commonly used as a carrier gas in the gas chromatography because it has excellent thermal conductivity, inertness and low density which allows the greater flow rate. इसका डेंसिटी क्या होता है? हेलियम का कम होता है, हाइड्रोजन का ज़्यादा होता है, नाइट्रोजन का ज़्यादा होता है. सो वो क्या करते हैं? वो थोड़ा सा प्रेशर बिल्ड करते हैं. सो दे ओके, उनका फ्लो रेट कम रखना पड़ता है इन दैट वे. दैट इज द कैरियर गैस. तो उसमें और भी आपका सेमेस्टर में आता है आइडियल प्रॉपर्टीज ऑफ कैरियर गैस के आइडियल प्रॉपर्टीज क्या होना चाहिए। तो वो सिंपल सिंपल होगा, इट शुड हैव हाईएस्ट हायर थर्मल कंडक्टिविटी, इट शुड बी इनर्ट, इट शुड बी इनर्ट, इट शुड बी इनर्ट, इट शुड हैव लो डेंसिटी, लाइकवाइज इट शुड बी इजीली अवेलेबल। ये सब आपके सेमेस्टर के लिए। रिमेंबर कैरियर गैस इज नथिंग बट मोबाइल फेज, hydrogen, helium, nitrogen, they are used as carrier gas. Out of that, helium is most commonly used as carrier gas. We'll see the next. Now, sample injection system. Okay, sample injection system. So for gas chromatography, okay, very small sample is required, and sample must be in a vapor form. There should be a system to introduce a sample in a reproducible manner. मतलब suppose that you have to inject the 5 microliter of sample, so there should be a such arrangement. Okay, there should be some calibrated syringes, there should be a calibrated autosampler, so that can inject 5 microliter only per injection. So that should be reproducible manner. So very small sample is required, and system must be introduced sample in a reproducible manner. Sample must be vaporized instantly. So sample तो क्या आप वेपर थोड़ी ही रख सकते, so you are using liquid sample mostly यूज होता है वहाँ पे solution में. There should be some system which can immediately vaporize the sample, okay? So that sample will enter into column at a single sludge. एक ही बार में बायोमाइक्रोलेटर सैंपल आपका सिंगल स्लज में आना चाहिए, बायोमाइक्रोलेटर 10 माइक्रोलेटर जितना भी आपका है। ओके, सो hypodermic needle was used, hypodermic syringes were used older days. Nowadays auto samplers are available, so there is no need to use these syringes and all that. ऑटो सैम्पलर है आजकल, मतलब यू जस्ट हैव टू प्रोग्राम इट कि आपको स्टैंडर्ड सैंपल जो आपका स्टैंडर्ड जो है उसका कितना क्रोमेटोग्राम निकालना, मतलब हाउ मेनी रन्स ऑफ योर स्टैंडर्ड। सो देर आर 5 रन्स नॉर्मली। सो नॉर्मली क्या होता है कि 5 स्टैंडर्ड सैंपल का इंजेक्ट करते हैं, उसका क्रोमेटोग्राम निकालते हैं, उसका जो पीक एरिया होता है, जो उसका सबका पीक एरिया का एक एवरेज उसका स्टैंडर्ड डेविएशन निकालते हैं। उसके बाद में मान लीजिए कि आपके पास एक बैच है, तो एक बैच के 2 सैंपल बनाते हैं, 2 सैंपल बनाने का, दोनों सैंपल का क्रोमेटोग्राम निकलने का उसका जो पीक एरिया आता है, वो पीक एरिया का एवरेज, एंड उसके बाद में उसका कैलकुलेशन होता है कि एरिया ऑफ सैंपल डिवाइड बाय एरिया ऑफ स्टैंडर्ड, देन डाइल्यूशन ऑफ स्टैंडर्ड डिवाइड बाय डाइल्यूशन ऑफ सैंपल इनटू 100 एंड ऑल दैट, जो बाकी फैक्टर वगैरह होता है, बाद में उसका परसेंटेज आएगा कितना सैंपल में परसेंटेज। ओके, सो सैंपल इंजेक्शन सिस्टम। then next one is nothing but the, okay, so carrier gas जो था later on, okay, now next part is nothing but the separation column. So column कैसा होना चाहिए gas column? Separation column, a column is constructed, okay, column is constructed or column is made up of a glass or metal tubing. यहाँ पे ग्लास का ट्यूबिंग रहेगा, ट्यूब्स रहेंगे लंबे लंबे, या फिर मेटल का ट्यूबिंग रहेगा, ग्लास का, स्टेनलेस स्टील का, या फिर टेफ्लॉन का, जो भी कॉपर का मेटल, कॉपर मेटल भी होता है, कॉपर मोस्टली नहीं यूज करते क्योंकि बिकॉज कॉपर कैन रिएक्ट विद द, so separation column is nothing but they are constructed by using glass or metal tubing, so 4.8 mm in the internal diameter, and they may be having length from few centimeter to up to 100 meters, which may be either straight, ये स्ट्रेट भी हो सकते हैं, which may be either coiled, जैसे अपने डायग्राम में देखा था कॉइल, कोई कॉइल अगर करेंगे तो स्पेस कम लगता है ना उसको, so it may be either straight or bent or coiled. There are two types of, two नहीं, actually there are three types of column used in the gas chromatography. So we'll see it one by one. So first is nothing but the, okay, so columns are made up of either glass or metals having diameter of 4.8 mm, length from few centimeter to 100 meter, and may be coiled straight, maybe straight or coiled or, okay. Now packed column, okay, now कितने टाइप की कॉलम होती है देखो, पैक्ड कॉलम, then open tabular column and support coated tabular columns are there, support coated open tabular columns. So there are three types of column, they are just mostly used in the chromatography, gas chromatography. So first is nothing but the packed columns. So जैसे packed column मतलब क्या है, पैकिंग किया है कॉलम में, ठीक है, कॉलम कौन सा रहेगा, स्टील या फिर जो भी, सो प्रिपेयर्ड बाय यूजिंग ग्रेनुलर स्टेशनरी, जो भी आपका ग्रेनुलर स्टेशनरी पेज रहेगा, ये spelling mistake है यहाँ पे, so so prepared by using granular stationary phase, and that stationary phase is packed in the metal or glass tubing. For gas solid chromatography it is packed with the graded adsorbent or porous polymer. जो भी गैस सॉलिड क्रोमेटोग्राफी होता है उसके लिए ग्रेडेड एडसॉर्बेंट और पोरस पॉलीमर होता है. नाउ इन केस ऑफ गैस लिक्विड क्रोमेटोग्राफी, so polymers, okay, gas liquid liquid is coated on a graded inert adsorbent solid support. जो graded inert solid support होता है उसके ऊपर there is a application of thin film of liquid for a gas liquid chromatography. Column should be okay. Now in case of packed column, column क्या होगा, bleed नहीं होगा. There is no column bleed in the packed column. मतलब column छोड़ेगा नहीं उसका. Bleed मतलब क्या है? So whatever thin layer of liquid you are applying on an inert support, so that thin layer should not be bleed. मतलब होता है ना, आपका कट हो गया तो ब्लीडिंग हो जाता है. In case of packed column, there is no bleeding or there is no column bleed. Most of the polymers which are used for the packing of column, they are also stable up to heat stable up to, I think they are stable up to 200 degrees Celsius. Again, in case of packed column, no baseline drift and allows the use of only, they are highly sensitive. They are sensitive to allow the use of sensitive detectors. So that is a packed column. यहाँ पे दो तीन टाइप की कॉलम होते हैं. पैक्ड कॉलम होता है, देन ओपन टेबुलर कॉलम होता है, देन कोटेड ओपन टेबुलर कॉलम. डिफरेंट टाइप की कॉलम होते हैं. सो पैक्ड कॉलम में क्या करना है आपको, यू हैव टू डू इन पैक्ड कॉलम. सो वट एवर एडसॉर्बेंट और पॉलीमर इज देयर, so that is graded and that is packed in the metal column, that is like glass column or your stainless steel column. Okay, for gas solid chromatography. Okay, for gas liquid chromatography, so liquid is coated on the graded adsorbent or solid support, inert solid support, and such that column is you want to use, that is a packed column. There is no adsorption of polar compounds like water, alcohol, acids. So in case of packed column, there is no adsorption of polar compound, only non-polar compound will be adsorbed over there, and they are eluted as a sharp peak. Again, when you are using packed column, no tailing and sample record is also rapid. So tailing नहीं होगा आपके chromatograph में, and आपका sample recovery भी rapid होता है packed column. और second type of column is nothing but the open tabular column. Tabular नहीं, tubular. Open tubular column. Open tubular column. So also known as a capillary column or गोले column. So remember इसके ऊपर भी question आ चुका है. Remember, so open tubular column, they are also known as a capillary column or गोले column. Now capillary column or गोले, so it will have a capillary of 30 to 90 मीटर, बहुत लंबा होता है. 30 to 90 मीटर कैपिलरी रहता है. हैविंग यूनिफॉर्म इंटरनल डायमीटर उसका होता है 0.025 to 0.075 सेंटीमीटर. मेड फ्रॉम आइदर स्टेनलेस स्टील और कॉपर और नायलॉन और ग्लास. Inside wall of this tube, they are coated with a thin uniform film of liquid, and carrier gas will experience very low resistance. And there is no, because there is no packing in this column. इसमें क्या होता है, इसमें जो ट्यूबिंग्स होते हैं, जैसे ग्लास ट्यूब हो गया, या फिर आपका स्टेनलेस स्टील हो गया, या फिर आपका नायलॉन हो गया. सो दीज ट्यूबिंग्स ऑफ दिस लेंथ 30 to 90 मीटर लेंथ रहेंगे. डायमीटर कितना रहेगा, सो ट्यूबिंग्स ऑफ either steel or copper or nylon, tubings having length of 30 to 90 meters and internal diameter 0.025 to 0.075 centimeter. So inside wall of this tubing is uniformly coated with a thin film of, so they are used for a gas liquid chromatography. Now carrier gas will experience very low resistance as there is no packing in the column. Okay, they are open tubular column, that's why they are known as open tubular column. तो उसमें ट्यूब रहेगा, ओपन ट्यूब, तो लंबी ट्यूब, उसका डायमीटर बहुत ही कम होता है. एंड सो देयर इज इनसाइड इन द ट्यूब there is a thin layer of liquid that will act as a stationary phase. Now support coated open tubular column. Support coated open tubular column. So made by depositing the micron sized porous layer of the supporting material on the inside of the wall of capillary, and then coating that wall with a thin film of liquid. Now support coated open tabular column is prepared in case of trace analysis. मतलब अगर if you want to analyze very small quantity of compound, then support coated tabular column is used. So ज़्यादा एक आध बार क्वेश्चन आ चुका है इसके ऊपर, कॉलम्स के ऊपर. So remember there are three types of column used in the gas chromatography. First one is a packed column. Okay, so where you are using metal or glass tubing, so whatever adsorbent for gas solid chromatography, that is a or adsorbent or porous polymer, okay, that is packed inside the tubing, that will act as a stationary phase. Now in case of gas liquid chromatography, that tubings are coated with the thin film of liquid. Liquid is coated on a size graded inert solid support in case of gas liquid chromatography. Now, in case of open tubular column, it is also known as a Golay column. A open tubular column जो है, it is also known as a capillary column or Golay column. ये एक याद रखो. Open tubular columns are also known as a okay capillary column or Golay column. ये इसके ऊपर capillary, it has a capillary of 30 to 90 meter length and internal diameter 0.25, 0.025, 0.025 to 0.075 internal diameter. They are either made from glass, stainless steel, copper. Inside all of these tubings, they are coated with the thin layer of liquid, thin film of liquid, and carrier gas will not experience much resistance over here because there is no support. जैसे पैक्ड कॉलम में होता है कि यहाँ पे पैकिंग किया है आपने, अंदर कुछ ना कुछ मटेरियल है, तो उसकी वजह से क्या हो रहा है कि गैस का फ्लो कम रहेगा, मतलब रेजिस्टेंस आएगा उसके बाद. सो देयर इज अ रेजिस्टेंस टू फ्लो द गैस और मोबाइल फेज इन द पैक्ड कॉलम. But in case of open tabular column, there is no resistance to flow the gas or mobile phase through a column because they are not packed with some adsorbent and all that. Again, support coated open tabular column. So for trace analysis, they are made by depositing the micron-sized porous layer, and then a thin film of liquid is applied on the porous support coated open tubular column used for the trace analysis. Now again you can see the components of gas chromatography. So this is known as a carrier gas, first component. So here will be a flow regulator. With second component, sampling system. So here either you use manual sampling or auto sampling. So desired amount of your mixture is injected inside the column. This carrier gas along with your sample. Carrier gas will take your sample inside the column and it will be separated according to the either adsorption or partition phenomenon. जो भी GLC है तो partition phenomenon, gas solid है तो adsorption. It will be separated. Okay, third component. This is nothing but the chromatographic column. This component is a chromatographic column. Okay, they are enclosed in a oven known as a oven, thermoregulator or temperature controlled oven. ये yellow color. Now fourth part is nothing but the detector. Okay, this part is nothing but detector. Then amplifier and recorder. Amplifier and recorders. Okay, these are the different components of your gas chromatography again. Now detectors, most important part of this gas chromatography, detectors. तो डिटेक्ट कैसे होगा और डिटेक्टर्स के ऊपर क्वेश्चन आता है. सो व्हाट इज रोल ऑफ डिटेक्टर टू मेजर द चेंजेस फ्रॉम कंपोनेंट अराइजिंग फ्रॉम इफ्लुएंट. जो भी कॉलम से मटेरियल आ रहा है, ठीक है, सेपरेट होके, तो उसका प्रॉपर्टी मेजर करना किसका काम है, डिटेक्टर का. ठीक है, कैरियर गैस का काम क्या है, इट विल एक्ट एज अ मोबाइल फेज. कैरियर गैस का करेगा, ये सैंपल को कॉलम में लेके जाएगा. जैसे नॉर्मल कॉलम क्रोमेटोग्राफी में क्या होता है, आप कॉलम लगाते हो, कॉलम के ऊपर सैंपल डालते हो, उसके बाद में मोबाइल भेज देते हो. तो मोबाइल भेज क्या करता है, आपके सैंपल को कॉलम से लेके जाता है. तो आपका सैंपल कॉलम के जो स्टेशनरी फेज है उसके साथ इंटरेक्ट करता है, मोबाइल फेज के साथ में इंटरेक्ट करता है. तो जिसका जितना एफिनिटी होता है वो वहां तक रहता है, तो वो सेपरेशन हो जाता है उसका. ठीक है, सो दैट इज द सेम फिनोमेना इन ओनली इन द गैस क्रोमेटोग्राफी. So detectors measure the changes from the component arising from effluent. Carrier gas without component will give you zero signal. जैसे सिर्फ कैरियर गैस से आ रहा है, ठीक है, आपने अभी तक सैंपल डाला ही नहीं उसमें, तो आपको एक जीरो सिग्नल आएगा, बेस लाइन आएगा. सो कैरियर गैस विदाउट कंपोनेंट will give you zero signal and you will get a baseline. ठीक है, ऐसा बेस लाइन आएगा आपको, कैसा ऐसा बेस लाइन आएगा आपको सिर्फ कैरियर गैस का. नाउ अगर आपके कैरियर गैस आया आपके कंपोनेंट के लेके, तो यहाँ पे सिग्नल आएगा इस वजह से, ये यहाँ पे एक पिक आया, दूसरा पिक यहाँ पे आ सकता है. सो व्हेन अलोन carrier gas is there, so it will not give any signal, so you will get a baseline. And when carrier gas along with the separated components will come at a detector, so there will be signal. Okay, and the signal will be in a proportion of concentration of that component. Okay, so detectors, they measure the changes in the component arising from effluent. Carrier gas, when alone will move, when alone will pass through detector, the signal will be zero or baseline, and if it is coming with the component, then obviously there will be signal in proportion to the concentration of detect of the compound on the detector. Okay, so there are different kind of detectors used in the gas chromatography. It's based upon the properties. हर एक का अलग अलग property है. So first is nothing but the thermal conductivity detector. First detector used in the gas chromatography known as a differential thermal conductivity detector. ठीक है, thermal conductivity. So it is also known as, इसको क्या बोलते हैं, differential thermal conductivity detector. Differential thermal conductivity detector, also known as catharometer, also known as catharometer or simply thermal conductivity detector. ठीक है, simply क्या है, thermal conductivity detector. It is the most commonly used detector in the gas chromatography. Thermal conductivity detector or catharometer or simply, okay, thermal conductivity. So thermal conductivity of gas is a function of the composition. Now change in the temperature and resistance of, okay, change in the temperature. So क्या होता है कि नॉर्मली गैस जो है आपका, उसमें अगर कोई कंपोनेंट नहीं है, इफ गैस इज अलोन, so it will have a different thermal conductivity, and if gas is with the component eluted, okay, so that will have a different thermal conductivity. So thermal conductivity of gas is a function of composition and change in temperature, and this, okay, this resistance of wire through which current is flowing is dependent on the thermal conductivity of gas in which it is immersed. So जब alone gas होता है तो उसमें थर्मल कंडक्टिविटी उसका डिफरेंट होता है. जैसे मान लीजिए, सो ये जो थर्मल कंडक्टिविटी डिटेक्टर होता है, so this thermal conductivity detector will have two platinum wires of uniform size, okay, which will form a part of Weston bridge. ये Weston bridge ये बनेगा उसका, दो platinum wire का. Okay, so one end of this platinum wire is always carrier gas is there. Okay, one side of this platinum wire, okay, so carrier gas always flow at the one end of this, and at the another end carrier gas along with the effluent or along with the component separated in the column, that is flow. तो एक जो वायर होता है कुछ इस तरीके से होता है, ऐसा स्क्वायर शेप. तो वन एंड, एक एंड पे क्या होता है कि कंटिन्यूसली कैरियर गैस मूव होते रहता है 0 से मिल के लिए. एक एंड पे कैरियर गैस प्लस आपका सैंपल जो रिलेटिव हुआ है वो आएगा. सो तो वहां में डिफरेंस आएगा. ओके, so two platinum wires of uniform size, okay, they will form a part of Weston bridge. One of them, okay, one of them is supplied with the carrier gas, and one of them, other of them is supplied with the column flow. Okay, एक में सिर्फ कैरियर गैस आता है, एक में क्या आता है, कॉलम फ्लो आता है. कॉलम फ्लो मतलब क्या, जो कैरियर गैस प्लस सैंपल. सो दिस वायर्स आर इलेक्ट्रिकली हीटेड. ये वायर्स क्या होते हैं, इलेक्ट्रिकली हीटेड किए जाते हैं, एंड दे एक्वायर्स इक्विलिब्रियम conduction of temperature and electrical resistance. When a carrier gas, okay, alone, okay, when carrier gas alone comes, there is no difference in the temperature. जब कैरियर गैस सिंपल कैरियर गैस अकेला आता है, वहां पे टेम्परेचर में कोई डिफरेंस नहीं होता है. सपोज दैट your carrier gas along with the separated components comes, so what will happen, the column, okay, so carrier gas along with the separated component from column, so it comes to this platinum wire. It changes the thermal conductivity and resistance of the wire. Now conductivity difference between your simple gas, carrier gas alone and carrier gas along with the component, so that is the recorded, amplified, and signal is given. Okay, so that is the working of your thermal conductivity detector. Okay, it has a low sensitivity. ये thermal conductivity detector का sensitivity क्या होता है, बहुत ही कम होता है. So it has a low sensitivity, and also this thermal conductivity detectors, they are affected by fluctuation in the flow rate of your mobile page, also affected by temperature, and they are not useful for biological samples. they are nothing but the disadvantage or demerits of your second detector is nothing but the flame ionization detector. So second one is nothing but the flame ionization detector. So it is based upon the electrical conductivity of carrier gas. Okay, so based upon the electrical conductivity of carrier gas at a normal temperature and pressure, your gas is act as an insulator. So at a normal temperature and pressure, gas acts as an insulator. It is not a conductor of your electricity. Okay, so normally at a normal temperature and pressure जो carrier gas होता है, that is nothing but the insulator. Act as an insulator, it will not carry any current or electricity, but becomes conductive when ions are present in that gas. So आपका जो gas है normally, so it is a non-conductor of your non-conductor or insulator. Normally whatever gas is there, carrier gas, that is a non-conductor or insulator of electric. But when, so that gas is along with the ions, gas will become conductor of electricity. Okay, normally at a non normal temperature and pressure, gas is insulator, but it becomes conductive if ions are present in that gas. मतलब अगर जो सेपरेशन जब नॉर्मली गैस गया डिटेक्टर पे, सिर्फ गैस गया डिटेक्टर के ऊपर, तो उसके ऊपर वो कंडक्टेंस नहीं दिखाएगा. गैस के साथ में अगर कोई इल्यूटेड सैंपल है आपका या फिर उसमें कोई आयंस है सैंपल के, दैट विल बिकम अ कंडक्टर. ओके, सो it is based upon the electrical conductivity of carrier gas at a normal temperature pressure. The gas will act as a insulator, but it will become a conductive in nature if ions are present. So hydrogen gas is most commonly used for this type of detectors. If other gases you are using as a mobile phase, then you have to mix other gas with hydrogen. ठीक है, जैसे बाकी गैस भी है उसमें भी अगर यूज करना है तो हाइड्रोजन को मिक्स करना पड़ता है. Okay, now when gas reaches to a burner, okay, of this detector, so burner is made of a platinum capillary which act as a cathode, and anode is nothing but the silver gauze placed above the burner tip. Okay, now working कैसे होता है देखो इसका. When only carrier gas is there, only when carrier gas passes through a burner, there is a no ionization and no current flowing in the gas with the component. Okay, one, but when gas with the components comes at a detector end, so okay, from column, number of ions produced because of the ionization and thermal energy. ठीक है, जैसे बर्नर में होता है कि थर्मल एनर्जी के रीजन के कारण आयोनाइजेशन होता है. जो नॉर्मल सिंपल गैस आ रहा है तो गैस का आयोनाइजेशन नहीं होता है, बट अगर गैस अलॉन्ग विथ योर सेपरेटेड कंपाउंड अगर दोनों के साथ में आ गया तो वहां पे क्या होगा, आयोनाइजेशन होगा उस कंपाउंड का. ओके, ड्यू टू थर्मल एनर्जी which causes current to flow, and that current is amplified and recorded as a signal. So this flame ionization detector is extremely sensitive detector. Background noise also is very less. It is a robust method, robust detector. Okay, any change in the flow rate or mobile flow rate अगर थोड़ा change होगा तो भी कोई फर्क नहीं पड़ता इसको. That is a flame ionization detector. So if you want to see the diagrams and all that, they are present in the book. You can go and watch. Now third one is a argon ionization detector. Argon ionization detector. So it depends on the excitation of argon atom to a metastable state. Radioactive energy is utilized to excite the argon molecules. तो argon molecule होता है नॉर्मल स्टेट में, ग्राउंड स्टेट में, उसको एक्साइट करने के लिए रेडियो एक्टिव एनर्जी यूज करते हैं. Okay, so that will become in a excite, that will go in a excited state. So depend on the excitation of argon atom to a metastable state by using radioactive energy, which is achieved by radiation of a carrier gas with alpha और beta. जो carrier gas है उसको ही alpha और beta पार्टिकल से रेडिएशन करो. जो आपका रेडियो एक्टिव को एलिमेंट्स होते हैं उसमें उसमें रेडियम हो गया आपका, या ड्यूटेरियम, ट्राइटियम, लाइक दैट. सो ये एक्साइटेड आर्गन पार्टिकल्स. अभी ये आर्गन पार्टिकल जो है एक्साइटेड आर्गन पार्टिकल और मेटास्टेबल आर्गन पार्टिकल्स, दे कोलाइड्स विद द इफ्लुएंट. जो भी आपका सेपरेटेड कंपाउंड है उसके साथ में कोलिजन होता है, एंड दे यूज टू ionize that separated molecule also. So these molecule also gets ionized, and ions, okay, if the ions increases the ions अगर total increase हुआ the current, okay, increases the current, and when they reach to a detector which is recorded and amplified एज अ सिल। तो यहाँ पे आर्गोन गैस जो है वो भी यूज करते हैं इसमें। तो आर्गोन गैस जो कैरियर गैस है वो यूज करते हैं, उसका एक्साइट करते हैं उसको स्टेबल से मेटास्टेबल में एक्साइट करते हैं बाय यूजिंग रेडियोएक्टिव एनर्जी। इट इज अचीव्ड बाय radiation of carrier gas with alpha and beta, irradiation of carrier gas with alpha and beta particles. Okay, when these particles will go in the detector, वहाँ पे जो argon gas है वो एक्साइट हो जाएगा, मेटास्टेबल में जाएगा, and that react with the separated particles and also ionizes with that separated molecules, and ions of these ionized they are collected, and ions are conductor of electricity, so current will flow and they will be detected. That is argon ionization detector. Last one is nothing but the इलेक्ट्रॉन कैप्चर डिटेक्टर, इसके ऊपर क्वेश्चन आ चुका है। सो फ्लेम आयोनाइजेशन डिटेक्टर के ऊपर भी क्वेश्चन आ चुके हैं। इलेक्ट्रॉन कैप्चर डिटेक्टर, सो इलेक्ट्रॉन कैप्चर यहाँ पे क्या है, इलेक्ट्रॉन से, ठीक है, इलेक्ट्रॉन कैप्चर डिटेक्टर। So the detector has a two electrodes. It has a two electrodes, एक एनोड एक कैथोड. When effluent passing between them, ये जो इलेक्ट्रोड्स थे, one of them electrode is treated with a radioactive isotope. इसमें इलेक्ट्रॉन कैप्चर होगा, इसमें दो इलेक्ट्रॉन होगा। एक इलेक्ट्रोड क्या है, एक इलेक्ट्रोड is treated with the radioactive isotope which emits the electron. एक इलेक्ट्रोड के ऊपर रेडियोएक्टिव आइसोटोप का उसके ऊपर रिएक्शन होता है, वो reacted with the radioisotope and that emit the electrons upon decay. जैसे रेडियोएक्टिव आइसोटोप होता है, उसका रिएक्शन होने के बाद में जो डिके होता है उसमें से इलेक्ट्रॉन निकले। Now these electrons also produce some secondary electrons, और भी कुछ secondary electrons produce करेंगे which are collected by anode which are provided with the potential of 20 volt. Now when carrier gas alone moves to a detector, जब carrier gas मतलब उसके साथ में कोई कंपाउंड नहीं, वो सिंपल कैरियर गैस है, तो जब वो डिटेक्टर के पास आएगा, सो सेम थिंग अगेन वो इलेक्ट्रॉन्स प्रोड्यूस होंगे, बट ऑल इलेक्ट्रॉन्स आर विल बी कलेक्टेड ऑन अ डिटेक्टर, सो उसका एक करंट रहेगा, ठीक है। नाउ व्हेन गैस अलोन कम्स टू अ डिटेक्टर, सो ऑल इलेक्ट्रॉन्स व्हिच आर इमिटेड बाय दैट रेडियोएक्टिव compound that will be collected and recorded. Now if your compound has a any electronegative atom, just like chlorine, bromine, iodine, etc., etc., okay, halogens. So if your eluted compound has a halogen, so that will acquire that electrons. तो ये जो इलेक्ट्रॉन्स निकल रहे हैं थिएटर में, तो नॉर्मली अगर कोई आपके कंपाउंड नहीं है उसमें, तो वो सब इलेक्ट्रॉन कैप्चर करता है डिटेक्टर और उसको मेजर करता है। लेकिन जब आपके कंपाउंड में कोई हाइड्रोजन कंटेनिंग एटम है, से आपका आयोडीन, ब्रोमीन, फ्लोरीन, ओके, क्लोरीन, या फिर दूसरे भी कोई इलेक्ट्रोनेगेटिव एटम्स है, सो दोज इलेक्ट्रोनेगेटिव एटम्स इफ दे आर प्रेजेंट in the gas as a effluent or as a separated component, so that whatever electrons are emitted due to decay of that radioactive stuff, they will be all will not be collected on reactor, because these electronegative atom will catch up that electron, so there will be difference in the electrons produced and electron receiving at the detector. So that is measured and amplified. Okay, so detector has a two electrodes. When effluent passing between them has a, so one of them, okay, one of them has a one of electrode has a treated with the radioactive isotope which emit the electrons upon decay. These electrons also produce secondary electrons which are collected at an anode, okay, when potential 20 volt is applied between them. When carrier gas alone flows, all secondary electrons they are collected by positively polarized electrode and baseline is recorded. When gas along with the eluted components comes which have affinity for electrons, they capture these electrons, electronegative atoms if are they are present, passes through electrode. Now steady state current is reduced. Difference in the current is recorded and amplified. Remember this electron capture detector, they are very sensitive for halogen atoms. Electron capture detector, they are very sensitive for halogen atoms. Question इसके ऊपर आ चुका है. They are very much sensitive for pesticides. जो pesticides होते हैं उसके लिए भी ये sensitive होता है. Electron capture detector, okay? They are very much sensitive for halogens, pesticides. Question आ चुका है इसके ऊपर वही. So following detector used in the gas chromatography is the most sensitive detector for halogen containing compound. अभी halogen की जगह आपको इलेक्ट्रोनेगेटिव एटम भी बोल सकते हो वहाँ पे, so don't confuse, okay. So ऐसा अगर क्वेश्चन पूछा कि following detector used in the gas chromatography is most sensitive for electronegative atom. So again electron capture device. So it is extremely sensitive, or it is a very sensitive in a nanogram quantity for halogen and pesticide containing compound. Nanogram quantity में ये sensitive होता है. Now next one is the selected stationary phases for gas liquid chromatography. तो ये stationary phases squalene है. Squalene का stationary phase which is a non-polar in nature. Squalene का जो stationary phase है वो non-polar होता है. Trade name उसका squalene होता है. ये ऑपरेट करता है इन अ टेम्परेचर रेंज ऑफ 150 डिग्री सेल्सियस एंड इसका एप्लीकेशन है लो बॉइलिंग एलिफेटिक हाइड्रोकार्बन्स, सेपरेशन ऑफ लो बॉइलिंग एलिफेटिक हाइड्रोकार्बन. एपिजिओन एल नॉन पोलर होता है इसका ट्रेड नेम है एपिजिओन एल. सो इट ऑपरेट एट 300 डिग्री सेल्सियस. So it is used to separate the amides, fatty acids, methyl esters, high boiling aliphatic hydrocarbons and terpenoids. तीसरा स्टेशनरी पे होता है polydimethyl siloxane. So it is a slightly polar in nature. So operation temperature is around 300 to 350 degrees Celsius. Separation of alkaloids, amino acid derivative, drugs, pesticides, phenols, that is done. ये सब गैस क्रोमेटोग्राफी के स्टेशनरी पेज है. 50% मिथाइल and 50% phenyl polysiloxane. Okay, polysiloxane. So it has a moderate polarity and operation temperature is nothing but 375. Used for alkaloidal drug, pesticides, polyaromatic hydrocarbons, polychlorinated biphenyls, etc. etc. 50% trifluorophenyl and 50% methyl polysiloxane. So moderately polar होता है. 275 डिग्री सेल्सियस ऑपरेशन टेम्परेचर है उसका. एंड यूज्ड फॉर द alkaloids, amino acid derivative drug, then halogenated compounds, ketones and phenols. इतना सारा याद नहीं रखना है आपको, ये जस्ट आपके लिए एक इंफॉर्मेशन है. सो अगेन ये सब कॉलम स्टेशनरी पेज की टाइप से 50% 50% साइनोप्रोपाइल, 50% फिनाइल मिथाइल पॉलीसिलिक्सेन सिलोक्सेन. सो ये पोलर होता है. 275 उसका ऑपरेशन टेम्परेचर है. Used for the separation of nitriles, pesticides and steroids. These are the different mobile phase. Polyethylene glycol भी होता है, that is a polar stationary phase. Operation temperature इसका कम होता है, that is a 225 degrees Celsius, and it is used for the separation of aldehyde, ethers, esters, phenols. Okay, so these are the stationary phases. Okay, different type of gas chromatography types होते हैं उसके. So first one is nothing but the packed column gas chromatography. जो packed column होता है adsorption रहेगा उसमें phenomena. In capillary column gas chromatography, तो very narrow column they are used. Mostly इसमें partition phenomenon होता है. In preparative scale chromatography, जब when you want your separated component, you want to isolate that, then preparative scale gas chromatography is there. Okay, then programmed scale chromatography, programmed gas chromatography. इसके ऊपर भी एक बार जीपैट पे क्वेश्चन आ चुका है. प्रोग्राम्ड टेम्परेचर गैस क्रोमेटोग्राफी मतलब इसमें क्या होता है कि इनिशियली आपको एक पर्टिकुलर टेम्परेचर सेट करना होता है. So for example, initially you have to set 50 degrees Celsius temperature, and after that you have to increase the temperature by 5 degree or 10 degree up to 300 degrees Celsius. So to produce the reproducible result, temperature of column is maintained at a suitable low temperature. For example, say example 50 degrees Celsius, and then temperature is increased at a control rate like 5 degree per minute or 10 degree per minute, 20 degree Celsius per minute, up to maximum 300 degrees Celsius. Because you should know what is role of temperature. जैसे टेम्परेचर होता है लो वोलेटाइल सोलूट है और एक थोड़ा सा उसका वोलेटिलिटी ज्यादा है, एक का कम है एक का ज्यादा है. तो जैसे होता है ना एचपीएलसी में कि आइसोक्रेटिक एंड ग्रेडियंट इल्यूशन. सो लाइकवाइज दैट. ठीक है. सो इफ टेम्परेचर इज kept constant, that is known as a, okay, that is known as a isocratic, and if temperature is changed, that is known as a gradient like. So it is a programmed temperature gas chromatography. So initially temperature is kept at a low temperature, for example जैसे 50 डिग्री सेल्सियस. आफ्टर दैट टेम्परेचर क्या होता है इंक्रीज किया जाता है किसका कॉलम का एट अ कंट्रोल रेट 10 डिग्री सेल्सियस 25 डिग्री सेल्सियस पर मिनट. Okay, so that is a programmed temperature gas to increase the efficiency of column. Derivatization of sample. Okay, derivatization of sample. सो इसमें दो आता है, प्री कॉलम डेरिवेटाइजेशन एंड पोस्ट कॉलम डेरिवेटाइजेशन। अगर आपका कंपाउंड जो है, इफ योर इल्यूटेड कंपाउंड्स आर नॉट सेंसिटिव, so to increase the sensitivity you have to derivatize that. So pre-column derivatization, if compound is less volatile, less thermal and less volatile and thermolabile, to reduce the tailing, to reduce the, to improve the separation factor, you have to pre-derivatize the column. So you have to use this derivatizing agent, bis trimethyl silyl acetamide BSA. So that is the reagent used to decrease the polarity of compounds like sugar, phenol, alcohol. Then your compound will be separated easily. So okay. Then again post column derivatization, again to improve the response of detector. अगर कोई compound आपका detector में response नहीं कर रहा है, so you can increase the efficiency of that detector by converting that compound to some another part. Let's say by increasing their ionization, by increasing their affinity towards the electrons. So these changes you can do. So known as the post column derivatization. Parameters used in the gas chromatography. It is very important part. So you have to remember. First one is the detention time. So the time spent by your compound in the column known as the detention time. So time difference between point of injection and appearance of peak maxima. Okay, that is the time required to remove a 50% of component from column. That is the retention time. जैसे मान लीजिए कि आपका आपने सैंपल ये पॉइंट भी इंजेक्ट किया और इतने टाइम पे रन आया आपका पूरा, और पीक आया मान लीजिए यहाँ पे ये 6 मिनट पे, ठीक है। सो इसका आरटी होगा 6 मिनट, रिटेंशन टाइम 6 मिनट। सो it is the time difference between point of injection and appearance of peak, that is a retention time. Okay, or time required to remove 50% of component from your column, that is a retention time, remember. एंड इट इज स्पेसिफिक फॉर पर्टिकुलर कंपाउंड। ये हर एक का अपना अपना कैरेक्टरिस्टिक होता है कि अंडर आइडियल कंडीशन, बाकी के जितने भी कंडीशन है, टेम्परेचर, फ्लो रेट, मोबाइल फेज, स्टेशनरी फेज, अगर वो कांस्टेंट है तो हर एक का कंपाउंड का आरटी क्या है, कांस्टेंट रहता है। सो दैट इज अ क्वालिटेटिव पैरामीटर। देन नेक्स्ट वन इज नथिंग बट रिटेंशन वॉल्यूम। So volume of carrier gas required to elute 50% component from the column. So volume of carrier gas required to remove 50% of component from column. That is a retention volume. Okay, denoted by VT. RT मतलब retention time, VT मतलब retention volume. So retention volume is nothing but the product of retention time into flow rate. मतलब retention volume को ऐसे calculate करेंगे, flow rate कितना है and RT कितना है उसके ऊपर. Then separation factor. So it is nothing but the ratio of partition coefficient of two components to be separated. So that is a separation factor. Ratio of partition coefficient of two components to be separated. Resolution क्या होता है? So separation of two different peaks having close retention time. अगर दो कंपोनेंट है उसका रिटेंशन टाइम एक का 3.5 है, एक का 4.2, मतलब बहुत ही नजदीक है, पीक डिफरेंशिएट होता नहीं। ओके, सो द एबिलिटी ऑफ your column to separate two components having close properties, that is known as a resolution. Separation of two adjacent peaks which are having close RT, उसका फॉर्मूला भी होता है। सो रेजोल्यूशन आर एस इज इक्वल टू ट्वाइस इंटू रिटेंशन टाइम ऑफ सेकंड कंपोनेंट माइनस रिटेंशन टाइम ऑफ फर्स्ट कंपोनेंट डिवाइडेड बाय width of first peak divided by width of second peak. W is nothing but the peak width. ठीक है, जैसे ये देखो यहाँ पे पीक है तो ये जो पूरा है इसको बोलेंगे पीक विड्थ। क्या है पीक विड्थ? पीक हाइट क्या है, ये ऊपर वाला पीक हाइट, पीक विड्थ। सो रेजोल्यूशन इज नथिंग बट द ट्वाइस इंटू RT2 minus RT1 divided by W1 plus W2, that is the resolution. Okay, now theoretical plates HTP we have already seen the HPLC, so same parameters also applicable for in the GC. कि theoretical plates कितने हैं? Column is divided into different theoretical plates where there is a actual equilibrium between your sample, mobile phase and stationary phase. So separation occurs at a small level or small theoretical plate. Okay, number of theoretical plate will increase, efficiency of column will increase. Okay, HTP means each theoretical plate have some hypothetical height. Okay, so height equivalent to theoretical plate. So number of HTP will increase, column efficiency will decrease. Now symmetrical factor. So ideally आपको peak क्या होना चाहिए, symmetric होना चाहिए. Your Ideally your peak should be symmetric like this. So whatever peak is there in first diagram, it is known as symmetric peak. So it is symmetric peak. जैसे आया यहाँ से आया, so this one is a symmetric peak. So first peak in this diagram is a symmetric peak. So ideally peak should be like this, symmetric peak. But sometimes due to change in the parameters, change in the flow rate of your mobile phase, change in the amount of injection, so what happens, peak symmetry goes. Okay, so peak symmetry goes. Okay, so due to that there is a fronting and tailing in the peak. So what is symmetry factor? So ideal symmetry factor should be 0.095 to 1.05. now what is meant by fronting? as you can see in this diagram, ये diagram में fronting दिखा है. ठीक है, fronting मतलब क्या है, ये जो initially ये बेस लाइन है, यहाँ से सीधा ऊपर जाना था, ये यहाँ पे कैसे सीधा ऊपर गया और नीचे आया. ये जो फ्रंटिंग मतलब क्या है, फ्रंटिंग मतलब स्लोली ऊपर गया वो इनिशियली और बाद में फटाक से नीचे आया. सो दैट इज अ फ्रंटिंग. सो यहाँ पे देखो जो सिमेट्री है आपका, सिमेट्री कैसे होगा इसका पिक का. ठीक है, जैसे ये सिमेट्रिक पिक है पहला वाला, ये देखो यहाँ पे सिमेट्री है पिक का. if you divide that peak into two part, a plus b, so a length of a will be equal to length of b, then it is known as symmetric. Okay, जैसे a का लेंथ बढ़ गया b से ज्यादा, दैट इज नोन एज फ्रंटिंग. तो फ्रंट से ही उसका, उसको बोलेंगे फ्रंटिंग. टेलिंग मतलब क्या, यहाँ पे लास्ट से ज्यादा, मतलब यहाँ पे इमीडिएटली ऊपर गया और यहाँ पे स्लोली नीचे है. सो इफ लेंथ ऑफ b is more than length of a, known as a tailing. Tailing and fronting are the commonly appeared troubles in the gas chromatography also and HPL search. So fronting is due to the saturation of stress in the phase. So you can decrease the fronting of peak by decreasing the quantity of sample. You can decrease the tailing. Tailing is because of the due to the more active adsorption sites. You can minimize the tailing by pre-treatment and मोर यूजिंग मोर पोलर स्टेरस. तो टेलिंग देखो, टेलिंग यहाँ पे भी दिखाया मैं, ये क्या है फ्रंटिंग. ठीक है, ये फ्रंटिंग एंड ये क्या है टेलिंग. these are the parameters you have to study in the gas chromatography. Now sensitivity of detectors, ये चार्ट है. thermal conductivity detector, thermal conductivity detector will have sensitivity of 10 raised to minus 8 linearity range 10 raised to 4. It is used for, it is known as a universal, it has a universal sensitivity and it is non-destructive detector. Flame ionization detector, it has a more sensitivity than former. इसका 10 raised to minus 11. It detects the organic compound. Most of the, okay, most widely used detector in the gas chromatography is the flame ionization detector, but it is a destructive. Sample is destroyed in this flame ionization. Thermal conductivity में आपका sample destroy नहीं होता है, so non-destructive. Now electron capture device or electron capture detector, sensitivity is 10 raised to minus 13. It will detect the halo मतलब halogen compound, nitro compound and phosphorus compound. Response varies significantly and it is also again non-destructive. Flame emission detector भी होते हैं, flame emission detectors. So उसका 10 raised to minus 6 sensitivity. So it is used for the sulfur and phosphorus compound. Response varies again destructive. Okay. Gas density balance detectors, ये भी होता है यूनिवर्सल डिटेक्टर होता है, लो सेंसिटिविटी नॉन डिस्ट्रक्टिव. argon ionization detector उसका सेंसिटिविटी होता है 10 to minus 12. again universal है. argon is a carrier gas, necessary and non destructive. argon ionization detector जो होता है उसमें argon as a carrier gas ही यूज करना पड़ता है. okay, some thermal analytical techniques. ये तो इसके ऊपर कभी क्वेश्चन आता है कि ग्राफ कौन सा किसका है. थर्मोग्राविमेट्री इज आल्सो नोन एज टीजी. तो इसमें इंस्ट्रूमेंट कौन सा यूज होता है, थर्मोबैलेंस. एंड पैरामीटर मेजर्ड इज नथिंग बट द मास, डिक्रीज इन द मास. ओके, सो मास वर्सेस टेम्परेचर और टाइम. सो ग्राफ क्या आएगा इसका, डिक्रीज इन द मास वर्सेस टेम्परेचर और टाइम, थर्मोग्राविमेट्री. नाउ डेरिवेटिव thermogravimetry known as a DTG, सेम इंस्ट्रूमेंट. ओके, बस यहाँ पे मेजर क्या करते हैं, डिक्रीज इन द मास विद डिक्रीज इन द टेम्परेचर, डीएम वर्सेस डीटी और सेम ग्राफ. अगेन डिफरेंशियल थर्मल एनालिसिस नेक्स्ट टेक्निक नोन एज अ डीटीए. डीटीए एपरेटस का उसका यहाँ पे क्या है, डेल्टा टी. change in the temperature is measured. So delta T versus temperature will be the graph. Then next one is the differential scanning calorimetry DSC. तो उसको बोलते हैं calorimeter. So what is measured? Delta H dt, dH dt. So change in the heat plus time. So dH versus dt, dH divided by dt versus temperature. So change in the heat with respect to time. Okay. So that is plotted against the temperature. Thermometric tritimetry calorimeter is used again. Temperature is the measured phenomenon. Temperature versus titrant volume. Then dynamic reflectance spectroscopy DRS. So spectrophotometer यूज करते हैं उसको रिफ्लेक्टेंस मेजर करते हैं परसेंटेज रिफ्लेक्टेंस वर्सेस टेम्परेचर उसका ग्राफ आता है. देन इवॉल्व्ड गैस डिटेक्शन EGD थर्मल कंडक्टिविटी सेल होता है उसके लिए थर्मल कंडक्टिविटी यहाँ पे मेजर करते हैं एंड ग्राफ आता है थर्मल कंडक्टिविटी वर्सेस टेम्परेचर. थर्मोकेमिकल एनालिसिस और डायलेटोमेट्री known as TMA थर्मोकंडक्टोमेट्री एनालिसिस थर्मोकेमिकल एंड देन डायलेटोमीटर यूज करते हैं इसमें वॉल्यूम एंड लेंथ मेजर करते हैं वॉल्यूम और लेंथ वर्सेस टेम्परेचर. इलेक्ट्रिकल कंडक्टिविटी EC सो इलेक्ट्रोमीटर और ब्रेड जेट एपरेटस यहाँ पे करंट मेजर करते हैं और रेजिस्टेंस मेजर करते हैं. सो करंट और रेजिस्टेंस वर्सेस टेम्परेचर ये ग्राफ रहेगा. दीज आर सम थर्मल मेथड्स. इमिशन थर्मल ETM उसके लिए ETS एपरेटस होता है रेडियो एक्टिविटी यहाँ पे मेजर करते हैं. So radioactivity versus temperature. ये ग्राफ आता है. So these are also sometimes they used to ask. So these are nothing but the different